Okay, here we are, 11.3, areas of regular polygons and circles. Regular polygons. All sides are the same, and therefore all of your angles are going to be the same, at least as long as it's a convex polygon, which is what we're going to be working with. So, regular polygons, all the sides are going to be the same, all your angles are going to be the same. And then, of course, areas of circles. Once again, that's one of those formulas that gets easily confused. And I will explain how these formulas are derived in class, at least with the circle. However, the regular polygon I'm going to do a little bit just because it just seems so out of the blue if I don't explain where that comes from. So I will show you at least kind of briefly how to do that in today's lesson as well. Yeah. Area of a circle. Why don't you write down what you think it's going to be first of all. Take a quick guess. Mostly because I have too many students write down what the circumference is. If area of a circle, I always think is the part, like if it's a pie, because you know pie is involved with circles, and it's the part that you eat. It's the inside part, and I myself love pie, and I'm sure many of you do as well. So you want lots of it. So you want pie. Here's a funny thing. I thought I had the formula underneath there. So you want pi r squared. All right, your radius, of course, is from the center to the side, and you just take it times pi, and then you have your area. Diameter is twice the amount of the radius, so you cannot say the diameter times pi. You have to take half the diameter and then square that. Okay, area of a regular polygon. You need to know what this word is. Apothem. It's the center of a polygon to the side, forming a perpendicular. Apothem. Oh, why don't you say that 3 times now? Let's all say it together as a class. Apothem. 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 All right. Here's what it looks like. You go from the center to the side. Forms a 90-degree angle. It cannot go anywhere else on this. You can't have it over here because then it's not going to form a 90-degree angle. You can't have it go over here. It's not going to form a 90-degree angle. It has to go center to the side so that it forms a 90-degree angle. So I'm going to draw in all of the, what are those called again? Apothems. All right. Same here with the hexagon. Let's show there, center to the side. Not the best drawing. Center to the side. Center to the side. And generally you are looking at the middle of the side. Center to the side. Not the best drawing once again, but you get the idea. Also works with triangles, and you're thinking to yourself, well, don't we already have a formula for the area of a triangle? Yes, we do, but sometimes we don't have the right information, and so we have to use an apothem to help us figure it out. So center, side, right angle. Center, side, right angle. Center, side, right angle. Okay, also, this formula down here, this 180 times the quantity of n minus 2 is also helpful. It will help you find something. It should look familiar. We talked about it earlier this year. Let's see, oh yeah, there we go. It's the sum of the degrees in any polygon. All right, so if you want to figure out how many degrees are in a pentagon, you take the number of sides, which is 5, you subtract 2, you get 3. 3 times 180 tells you how many degrees are in a pentagon. And then because this is a regular pentagon, you divide by 5, and that tells you how many degrees in each one of these. All right, and that works here. Hexagon. 6 sides. 6 minus 2 is 4. 4 times 180. Figure that out. Divide by 6, and that'll tell you how many degrees are in each one of those angles. And all those angles are congruent again. Same with the triangle. Moving on. You might also need to know SOHCAHTOA for this lesson. Sine. Once again, this will be the last time I go over this. You need to know this. Sine is opposite over hypotenuse. SOH. Cosine. Adjacent over hypotenuse. CAH. Tangent. Opposite over adjacent. TOA. All right, this crazy thing right here. This is something I would have done in class normally, but I'm going to quickly run through it. On this first column, have taken and drawn in all those apothems. Woo, 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 apothem, 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 all over the place. All right, now in the second column, I have drawn in just one, and I've made a triangle around that one. All right, I did the same thing here with the square. There's my apothem is in blue. The triangle forms out with the green. All right, and then we find the area of one triangle. So I'm going to move this here. What is the formula for the area of a triangle? 1/2 base times height. All right, what's the area of this triangle right here? 1/2 base times height. This triangle, 1/2 base times height. This triangle, 1/2 base times height. But guess what? That height is in blue. What do we know that blue piece as? Oh yeah, the apothem. So instead of writing 1/2 base times height, I could write 1/2 base times apothem. I'm replacing apothem with height because that's what it is in that picture. You're like, where are you going with this, Mrs. Talley? We'll keep watching. All right? Now, if I take this triangle and, oh, look at the fun we're going to have right now. Take this triangle and I try so nicely to move that in here. Once again, it doesn't matter if I'm in class or not in class. Can you see what I was wanting to do here? We're going to move these just out of the way just so it doesn't take forever. All right, so I am going to have a triangle here. Oh, goodness. I'm going to, the same things happen in classes on recordings. All right, there's my triangle. I've got 3 of them. And I could do the same thing here. I have a triangle, but wait, I would actually have how many triangles? 1, 2, 3, 4. So I would take 1/2 base times apothem times 4, because I have 4 triangles. Here I would take 1/2 base times apothem times 3, because I have 3 triangles. Oh yeah, 3 triangles is like 3 sides. 4 triangles, 4 sides. Oh, and this pentagon, I have 5 sides. So wouldn't that be like 5 triangles? All right, and then I have 1/2 the base times the apothem times 6. Do you see what's happening? Kind of a little pattern. Here's what I want to point out. If I have a base and I have 6 of those bases, what does that end up being? Oh yeah, that's a perimeter. So couldn't I say instead of a base times 6, couldn't I say 1/2 A and base times 6 is actually my perimeter? Let me try that up here. Look at 5 of these bases. That's how many triangles I have is 5. And every base times 5 gives me the perimeter. So this would be 1/2 A times the perimeter. 1/2 AP. P stands for perimeter. 1/2 AP. It happens in every case. So our area of any regular polygon, whether it's a hexagon, a pentagon, or any regular polygon, is going to be 1/2 AP. A is your apothem, P is perimeter. And that's just the way it is. That's the formula. This I will not show you in class. I just wanted you to see where that came from. It's not completely out of the blue. So put down A for regular polygon. The area is 1/2 AP. Beautiful. Moving on. Okay, example problem. So on to the next video.